Now, programs often need to keep track of the state of some kind of condition. Let's say you're writing a program that simulates the operations of a garage door opener, and you'll need to keep track of the state of the garage door's direction. Is the direction up or down? You need to track the direction state because the direction determines what happens when the garage door opener's button is pressed. If the direction of the state is up, then pressing the garage door's button will cause the direction to switch to down. And if the direction state is down, then pressing the garage door button causes the direction to go up. And to implement the state of some condition, we often use a Boolean variable. Now, a Boolean variable is of type Boolean, and it only holds true or false. In our garage door example, we could create a Boolean variable called up direction. And if the door is going up, then it's set to true. And if it's going down, it's set to false. Likewise, we could probably use another variable to track the state of whether or not the door is actually in motion. Like this. This code fragment initializes an up direction variable to true and shows how to toggle its value within a loop. And this is a common technique to invert the state of a Boolean variable. You see here we simply apply the not operator to assign it back to the original variable. So if it's not up direction, then it becomes this, and vice versa. So here we have the author's garage door class. And you can see here he's got his variables that we've already discussed in his main method. He's got a do loop, and the user is going to press enter or Q to quit. And so it's going to get this entry, and if it says while it does not equal enter or Q, prompt the user again until they enter or Q. And so if the entry equals enter, which is what the empty quote is, then go ahead and set in motion to not in motion. So this is going to toggle whether it's in motion or not. And if it's in motion, and if the up direction is true, and that's what this code does right here, if the up direction is true, you don't have to say if it's equal to true. Okay? You can just use the Boolean variable, because if it's true, it's true. Then print moving up, and if it's not in the up direction, print it's moving down. Otherwise, else, so we're matching up with this if right here, if it's not in motion, then print it's stopped, and set the direction that it's traveling in the opposite direction. Oops, got an extra space there. Okay? And that's all that it does. So if we compile this, you can see that it compiled successfully. We run it. It's a really basic program. Enter or Q. All right, well, let's enter. Hey, we're moving up. Hey, we stopped. Hey, now we're moving down. And we stopped. And now we're moving up. And we stopped. All right, I feel like my kid's playing with my garage door opener. Down, stopped, up, stopped. All right, enough of that. So you can see there the power of using the Boolean variables and the do while loops nested within the while loop. So we're using the while loop here for control for user input checks to make sure that they're entering a Q or an enter, and then we're executing some code based on some logic. To wrap up this chapter, you need to make sure that you have a good understanding of Boolean algebra. Boolean logic, or Boolean algebra, is the formal logic that determines how conditions are evaluated. The good news is that we've already covered all the operators you'll need at this point to know. So you've got the logical and, the logical or, and the not operator. Remember that with the and operator, both operands, both sides need to be true for the whole thing to be true. So both sides need to be true in order for it to evaluate to be true. For the OR operator, only one side needs to be true. All right, so left side, right side, doesn't matter. Now, as a performance tip, you put whichever condition you think is more likely to be true first, because that way, once it encounters a true statement, it won't evaluate the rest of it. So always put the more logical thing, or the thing that's most likely to be true, first. And then finally, the not operator reverses the truth or the falsity of something. So that's it. That is Chapter 4, Unit 4, whatever you want to call it. We talked about quite a bit of stuff, but not nearly as much as we did in Chapter 3. Hopefully you took the time to do the examples when I paused the video. Again, I can't foot stomp this enough. You need to practice, practice, practice. That's the only way that you're going to get better at writing the code, especially without having to look up examples, because you probably are not going to be able to do that on the final exam. So you're going to want to know how to write a class from scratch, including the class header and the main method and all that. So we covered if statements. So basically it's a fork in the road, right? We covered logical operators, the logical and, or, and not operator. We also covered a switch statement, which allows you to clean up some of the nested or chained if statements. If you get a lot of if, else, if statements, then you might want to look at a switch statement to clean up the code. And we're going to do some examples of that in class so you can get some practice with it. We also looked at loops, while, do, and for, and we kind of compared them. We talked about them, how to nest them to accomplish certain things. Later on in the course, of course, we'll also talk about program complexity and how having a lot of nested loops can really slow down your program. A lot of times you can't help it, but it also just depends on the algorithms that you're trying to implement. But we'll get into a lot more of that later. Finally, we talked about Boolean variables and Boolean logic and how you can use them for input validation and keeping track of states of things. So hopefully the video lesson helped go through the content of the book. And if it's not, make sure you give me some feedback in class so I can improve the videos.